On this problem, we're told that these two triangles are similar to one another, and we're given these corresponding sides of 8 centimeters and 6 centimeters. Now remember, we can either look at the labels as just being centimeters, or we could be talking about, hey, we're talking about sides, but that is giving us a one-dimensional ratio of 8 to 6. Or we could reduce that. Both of those are divisible by 2. We could talk about our one-dimensional ratio, because we're talking about sides of a triangle, and notice the label is in centimeters. That would be our 1D ratio. But then we are asked to find the area of the larger triangle. Now area, we're given the area of the smaller triangle is 45 centimeters squared. Centimeters squared, check out the label, it's squared. We're now talking about two-dimensional. All right, anytime we're talking about area, it is two-dimensional. We're given the area of the smaller triangle to be 45, looking for the area of the larger triangle. So I need to have a two-dimensional ratio to be able to solve a two-dimensional problem. So I'm going to take my 4 to 3 and I will square each of those for my 2D ratio. 4 squared is 16, 3 squared is 9. I have to use my 2D ratio to solve a 2D problem. We're talking about area here. Notice our label was centimeters squared. That squared's telling you you're two-dimensional. All right, anytime we're talking area, it's two-dimensional. So then I would set up my proportion. 16 is to 9, using my 2D ratio, is equal to, we were given the area of the smaller triangle. That would go with the smaller number. In this case, we put it on the bottom. So the 45 goes on the bottom. We're looking for the area of the larger triangle. And now from here, we just cross multiply and solve like we do on all of our other proportions. And so I would take 9 times A is equal to 16 times 45. And then I divide both sides by 9. And we would find that the area of the larger triangle would be 80 centimeters squared.